Welcome everybody. We are given a quadrant. We have a circle and a semicircle. We're expected to find the radius of the semicircle. So foremost, let me take this point as P and the radius to be equal to say R. So this is obviously going to be equal to R. So the diameter is 2R. So that means this radius for the quadrant is going to be 2 times R. We are given the smaller circle's radius to be as 2 units. Okay, so that is the first step in this problem. And what I'm going to do is I would construct a triangle. That's my objective. Now there is a point of tangency between the circle and the semicircle. Since there is a point of tangency, okay, between the circle and semicircle, so this means by tangent theorem, the line drawn through the point of tangency of the circles will pass through the center of the circles. So if I were to draw this line through the point of tangency, it is going to hit the centers. Now let me have this as some point Q. Okay, and what I wish to do is I would like to also consider the point of tangency between the circle and the quarter circle. Also there is a point of tangency between the circle and the quarter circle. So this means the line drawn through the point of tangency will pass through the center. So center, when we talk about center, we're talking about the center of the circle. So we have a center here, we have a center here. So I will actually complete it. So we have a triangle that has been created. Okay, so clearly this distance is 2 units. This distance is this is the radii of the quarter circle. So this distance is going to be R. So PQ is going to be R positive 2. Now you drop a perpendicular. If I were to drop a perpendicular, then that perpendicular will be the bisector that is dividing OP into 2 parts. So I'm going to be dropping this. Okay, so this is 90 and this will also be 90. This will be the height of the triangles. Now this entire length is R, and clearly this distance is actually the radii, right? It's perpendicular to the point of tangency. There is also a point of tangency here. So this entire length is going to be 2. If this is R, this distance is going to be R negative 2. Okay, so the idea here is to treat the two, or I would say this triangle, to be two right triangles and equate the heights. Now clearly this is 2 units, and this entire length is actually the radii of the quadrant. This entire length is going to be 2r. From 2r you take away 2, you get this length. So 2r minus 2 will be this length. So with that being said, we will consider the 2 triangles, or 2 right triangles. Consider triangle OQP. Consider triangle OQP, which is equal to triangle OQR plus triangle, I would say ORQ. So instead of saying OQR, I will say triangle ORQ plus triangle PRQ. Okay, so consider triangle ORQ. So this is how the triangle looks. ORQ is looking like this. So this is O, this is Q, and this is R. So with that being said, this is 90 degrees actually. It should be 90 degrees. Okay, 90 degrees. So this distance is 2 units. This is my height. I'm going to take it as h. This distance is 2 times r minus 2. So by Pythagoras theorem, what do we have? We have OR squared plus RQ squared is OQ squared. So OR squared is 2 squared. RQ squared is not known. And this is going to be 2 times r minus 2 the whole square. Now when I say RQ squared is not known, it means that we are going to be equating it. So from here RQ squared is equal to 2r negative 2 the whole squared negative 2 squared, which is 2r negative 2 the whole squared minus 4. This is my RQ squared. I'll take it as equation 2. Now next you consider triangle PRQ. So PRQ, if I were to draw PRQ, this is how it looks. So this is R, this is Q, this is P, this is 90 degrees. So by Pythagoras rule, so what do you have? You have QR squared plus RP squared is equal to QP squared. Now this distance QP squared, see this is R, this is 2, R positive 2. Right, QP squared is going to be R positive 2 the whole squared, and this is QR squared plus RP squared. So what is RP squared? RP squared is 2 R negative 2. So R negative 2 squared. So QR squared is equal to R positive 2 squared negative R negative 2 squared. This is what we've got. So this is going to be 3. So what I will do is equating 2 and 3 we get. So what do we get? So RQ, so we are going to be equating 2 with 3. So this is going to be 2r negative 2 the whole squared negative 4 is equal to r positive 2 the whole squared negative r negative 2 the whole squared. So the right hand side, this is r squared plus 4 times r plus 4 negative r squared, right? And this is negative 4r, it's positive 4r, positive 4, so negative 4. This and this gets cancelled, these two gets cancelled. This is going to give me 8r. To simplify this, this is going to be 4r squared, 4 8r positive 4 negative 4 is equal to 8r. Positive negative goes off. You got 4r squared negative 8r. Negative 8r. In fact, you can push this to the other end. So you get 4r squared is equal to 8r plus 8r. So 4r squared is equal to 16r. You divide by 4 both sides. You get r squared is equal to 4r. You can actually bring this to the other end. So you get r squared negative 4r is equal to 0. You take r out, you get r negative 4 is equal to 0. So from here r is equal to 0 or r negative 4 is equal to 0. So this cannot happen. So r minus 4 is equal to 0 is taken. So r is equal to 4 is the value. So therefore the radius of the semicircle is 4 units. So that's the solution for this question.